Hello students, in this video let us learn some more problems on Fourier transforms. Let us just recall the Fourier transform of a function f of x is defined by f of x is equal to integration of f of x into e to the power isx dx where the limits of x are varying from minus infinity to infinity. Then the inverse Fourier transform of the function is given by f inverse of f of s is equal to 1 by 2 pi integration f of s into e to the power minus isx ds where the limits of s are varying from minus infinity to infinity. Just make a note of here students, where your capital F of s over here indicates the Fourier transform acting on the function f of x. To find the Fourier transform of the function f of x is equal to x for mod x less than or equal to a and 0 for mod x greater than a, where your a is positive. From the definition of Fourier transform, the Fourier transform of the function f of x is given by integration f of x into e to the power isx dx where the limits of x are varying from minus infinity to infinity. Just make a note of it students, mod x less than or equal to a implies your x lies between minus a to a. However, the given function f of x is defined in the whole real line, but for all those mod x greater than a, the function value is 0, right? So, in order to find the Fourier transform in the interval minus infinity to infinity is same as finding the Fourier transform in the interval minus a to a, because outside this interval the function value is 0. So, evaluating the Fourier transform in the interval minus a to a and the function f of x in the interval minus a to a is x into e to the power isx dx. Using the Bernoulli's rule, by choosing the first function as x and second function as e to the power isx dx, so that the above integral reduces to the form first function, that is x into integration of second function. What is the integration of e to the power isx? With respect to x, it is e to the power isx divided by is, where the limits of x are varying from minus a to a, minus differentiation of x. What is the derivative of x students? It is 1 into integration of e to the power isx by is, that is nothing but e to the power isx divided by is whole square, where the limits of x are varying from minus a to a. Apply the limits and observe that cos x can be written as e to the power ix plus e to the power minus ix by 2 and sin x can be written as e to the power ix minus e to the power minus ix by 2i. Just taking a common or just taking a outside the bracket and observing that e to the power I into as plus e to the power minus I into as can be written as 2 into cos as plus 1 by s square into, observe that e to the power I into as minus e to the power minus I into as can be written as 2 into I into sin as. If you want, you can simplify or else leave at this point itself. So, this is the required Fourier transform of the given function. Next problem, that is to find the Fourier transform of the function f of x is equal to 0 for all those x less than a, 1 for x lying between a and b and 0 for x greater than b, where your both a and b are positive. From the definition, the Fourier transform of the function f of x is given by integration f of x into e to the power isx dx, where the limits of x are varying from minus infinity to infinity. Just observe the given function f of x, students. The function value is 0 for all those x less than a and greater than b, right? So in order to find the Fourier transform in the interval minus infinity to infinity, it is enough to find the Fourier transform in the interval a comma b, because outside this interval the function value is 0. So the above integral reduces to the form integration 1 into e to the power isx dx, where the limits of x are from a to b. What is the integration of e to the power isx? It is e to the power isx by is, where your x is varying from a to b. Apply the limits. So by applying the limits, the above equation changes to the form 1 by is into e to the power ibs minus e to the power I into as. That completes the problem. Next example, to find the Fourier transform of the function f of x is equal to 1 minus mod x for mod x less than or equal to 1 and 0 for mod x greater than 1. And hence they are expecting you to find the value of the integral sin square x by x square for all those x varying from 0 to infinity. Let me first concentrate on the Fourier transform and evaluate the integral in the later stage. From the definition of the Fourier transform, the Fourier transform of the function f of x is given by integration of f of x into e to the power isx dx, where the limits of x are varying from minus infinity to infinity. Just observe the given equation, students. The given function, the function value is 0 for all those mod x greater than 1, which implies the function value is 0 for all those x lying outside the interval minus 1 to 1. So it is enough to evaluate the Fourier transform in the interval minus 1 to 1. And what is the function in the interval minus 1 to 1? The function is 1 minus mod x, right? And from the definition of mod x, we know that mod x is equal to minus x for all those x less than 0, and it is equal to x for all x greater than or equal to 0, right? So let me divide the interval minus 1 to 1 as minus 1 to 0 and 0 to 1. And in the interval minus 1 to 0, what is your mod x value? The mod x value is minus x, because it is given that for all those x less than 0, the mod x value is minus x, right? Therefore, in the interval minus 1 to 0, the mod x value is minus x, whereas in the interval 0 to 1, mod x value is positive x or just x. Now evaluating these two integrals using Bernoulli's rule by choosing the first function as 1 plus x over here. So what you are going to get? First function into integration of second function. What is the integration of e to the power isx dx? It is e to the power isx divided by is minus differentiation of the first function. What is the derivative of 1 plus x with respect to x? It is 1 into integration of the second function, that is e to the power isx by is is e to the power isx divided by is whole square, where the limits of x are varying from minus 1 to 0, plus evaluating the second integral using Bernoulli's rule by choosing the first function as 1 minus x. So 1 minus x into integration of second function, that is e to the power isx by is minus differentiation of 1 minus x. Derivative of 1 minus x is minus 1 into integration of second function, which is nothing but e to the power isx divided by is whole square, where the limits of x are varying from 0 to 1. applying the limits and simplifying the equation so that the Fourier transform of the function is equal to 4 into sine square s by 2 divided by s square. But however, this is true for all those s not equal to 0. But if I want to check what is the Fourier transform in the closed neighborhood of s is equal to 0 or at s is equal to 0, then the Fourier transform at s is equal to 0 is equal to limit s tending to 0, the Fourier transform of the function. What is the Fourier transform of the function, students? It is 4 into sine square s by 2 divided by s square. Over here, I have written 4 by s square as s by 2 whole square. Okay. As s tending to 0, sine square s by 2 divided by s by 2 whole square will be tending to 1. So that completes the Fourier transform of the function. Now let us evaluate in order to find the value of the integral sine square x by x square as x tending to 0 to infinity. Let me use the inverse Fourier transform of the function, which is given by f inverse of f of s is equal to 1 by 2 pi integration of the Fourier transform of the function multiplied with minus e to the power minus isx ds, where the limits of s are varying from minus infinity to infinity. Just substitute the Fourier transform of the function, that is sine square s by 2 whole square. Now just observe the integrand of the inverse Fourier transform and that of the desired result. In order to get the integrand of the desired result, let me substitute a particular values for x. Say suppose x is equal to 0. So by substituting x is equal to 0, the equation reduces to the form f of 0 is equal to 1. Just make a note of it, students. The function is defined as 1 minus mod x in the interval, closed interval minus 1 comma 1. Since 0 is a term that lies inside the closed interval minus 1 comma 1, so the function value at x is equal to 0 is 1. That is equal to 1 by 2 pi integration sine square s by 2 divided by s by 2 whole square, where the limits of s are varying from minus infinity to infinity. Let me simplify the integral by substituting t is equal to s by 2, so that dt is equal to 1 by 2 into ds. So the above integral changes to the form 1 is equal to 1 by pi integration minus infinity to infinity sine square t by t square dt. But just make a note of the function, students, whether sine square t by t square is an even function. Yes, it is an even function. Evaluating the even function in the interval minus infinity to infinity is same as evaluating the function in the interval 2 times 0 to infinity. So the integral minus infinity to infinity changes to the form 2 times 0 to infinity sine square t by t square dt. Just rearranging the terms so that the value of the integral sine square t by t square, where t varying from 0 to infinity is pi by 2. That completes the problem. Last problem on Fourier transform, that is to find the Fourier transform of the function f of x is equal to e to the power minus a square x square and deduce that e to the power minus x square by 2 is self-reciprocal with respect to the Fourier transform. Let us first find the Fourier transform of the function e to the power minus a square x square, and using it we are going to deduce that e to the power minus x square by 2 is self-reciprocal. From the definition of the Fourier transform, the Fourier transform of the function f of x is given by integration of f of x into e to the power isx dx, where the limits of x are varying from minus infinity to infinity. Substitute the function f of x by e to the power minus a square x square and simplify it so that the integral changes to the form integration minus infinity to infinity e to the power, I am just taking a square common from these two terms, minus a square common, so that the terms inside the brackets will be of the form x square minus isx by a square. Just observe the terms inside the bracket, students. Let me make it a perfect square. It is of the form now a square minus 2ab or x square minus 2xy. So what is your 2xy over here? 2xy is isx by a square, or y is equal to is by 2a square. In order to make this as a perfect square, let me add and subtract y square to it. So adding and subtracting y square and observing that the first term inside the bracket is of the form a square minus 2ab plus b square form, isn't it? So I can write it as a minus b whole square minus is by 2a square whole square. So the integral reduces to the form integration minus infinity to infinity e to the power minus a square into x minus is by 2a square whole square minus is by 2a square whole square. Just splitting the terms over here, so that the integrand is of the form e to the power minus a square into x minus is by 2a square whole square into e to the power a square, minus into minus, it is plus over here. So it is e to the power a square into is by 2a square whole square. Just observe the term over here, students. E to the power my a square into is by 2a square whole square is independent of x. Okay, so I can take it outside the integral over here. So the equation is of the form e to the power a square I square s square divided by 4 into a to the power 4 integration e to the power minus a square into x minus is by 2a square whole square, where the limits of x are varying from minus infinity to infinity. Let me simplify the above integral by substituting t is equal to a into x minus is by 2a square, so that dx is equal to dt by a. So the above equation changes to the form. Just observe over here, I square is nothing but minus 1, so it is minus a square by 4 into a to the power 4 is 4a square, and dx is replaced by dt by a, and 1 by a I have taken it outside the integral, so that the integration is of the form e to the power minus t square dt, where the limits are varying from minus infinity to infinity. And the value of this integral, it's a standard integral which is nothing but gamma half, and we know that the value of gamma half is root pi. Therefore, the Fourier transform of the function e to the power minus a square x square is root pi by a into e to the power minus s square by 4a square. That completes the first part of the question, students. Now to deduce that e to the power minus x square by 2 is self-reciprocal with respect to the Fourier transform, we will first analyze what you meant by the self-reciprocal. Self-reciprocal is nothing but the Fourier transform of the function should be proportional to the given function, and the given function over here is e to the power minus x square by 2 at x is equal to s, or that is nothing but f of s is equal to k into, where k is some proportionality constant, into the function value at x is equal to s. Right now we have the Fourier transform of the function e to the power minus a square x square, isn't it, which is given by root pi by a into e to the power minus s square by 4a square. Now to get the Fourier transform of e to the power minus x square by 2, Let me just substitute the value of a square as 1 by 2 in the above expression itself. Okay, I am just substituting a square is equal to 1 by 2. Therefore, the Fourier transform of the function e to the power minus x square by 2 will be equal to a square is equal to 1 by 2 is nothing but a is equal to, I am just taking the positive square root itself, that is 1 by root 2, right. So, substituting a as 1 by root 2. So, denominator will go to the numerator. So, the equation is of the form root 2 pi into e to the power minus s square by 2, that is equal to root 2 pi into, this is nothing but your function, right, at x is equal to s. So, you have proved that the Fourier transform of the function is equal to some constant into the function, the given function at x is equal to s, right, which proves the self-reciprocal property of the given function here, that is e to the power minus x square by 2. So, that completes the problem. Thank you.